Hey, Alex,
Hello?
can you hear me?
Yeah, I sure can.
Awesome. I had a statistics question that has like three parts. I was wondering if you could help me with it.
Sure. Yeah. What's the question?
It says the average age of a Valencia student is 24.1 years old with a standard deviation of 1.9. And then it says find the ages of the following.
Okay.
And then part A, want to know the cutoff for the top 10%. Part
Okay.
B is the cutoff for the bottom 20%. And then part C, what separates the top from the bottom.
Okay. And that was top 10 and bottom 20, right?
Yeah, part A, top 10, part B, bottom 20, and then part C was what separates the top from the bottom.
Okay. So if it's okay with you, I'm actually going to change these numbers slightly. I'm just going to round them so it'll be 24 and 2. I'm going to do that because then I can show you all the steps and everything. But as you know by now in this class that if you change something even by one decimal point, it can drastically change your final results. And so then after showing you
Okay.
the rounded numbers, you could walk me through how you do it with your actual numbers. Does that sound fair?
Yeah, that's cool.
Okay. Let me just write this here. Okay, so for part A, let's see here. We're trying to do the top 20, top 10%, and I'm going to round these, like I said, so that'll be 24 and 2. So
And 24, those are the numbers you're going to use, right?
those are the numbers I'm going to use just to show you the
Okay.
process.
Okay.
So then, if you had the normal distribution here, so if I just sort of drew this here, and we want the top 10%, so let's say that's like right there, so that would be this. Do you agree that the alpha here, as far as like the area that would be underneath from here, would actually be 90% or 0.9?
Yeah, I remember the teacher pointing that out, that always look at the bottom value.
Yeah, it's always left to right. So you go up to some value and then everything below that.
Okay.
Okay, cool. So if we have that, now there's two ways we could start approaching this. You can either use a z-table or you can use the calculator. I'm going to show you how to do both, but then afterwards we'll do it whichever way you'd prefer. So
Okay.
I'll do the z-table one first. So if you had the z-table, then what you would do is you'd look up an alpha of zero point 0.9, but remember the entries in the table are your areas, right? And then on
Okay.
the rows and columns are your z-scores. So what I
Okay.
have is an area. Is this making sense so far?
Yeah.
Okay, cool. So zero point 0.9, if you look in this, there's not actually something that's just zero point 0.9 even. So you have to look for something that's really close. And the two numbers I find are 0.8997 and 0.9015. You just take whichever one's.
Okay. Hey, I'm grabbing my Z table and following along. Okay. Yeah, yeah,
Found those two values there?
yeah.
Okay, cool. So the way you decide which one to use is that you notice the 0.8997, that's three values in the thousands place away from what you actually want. Whereas the other one is
Right.
like 0.0015 away, it's further away. So we're going to take the 0.8997 because that's closer.
Yeah, we're looking for the closest one. Okay. I
Okay,
remember this. Yeah.
so this is about 0.8997. And then from that, you just look at what your z-score was that gave you that. So if I look at this and I go over to the left with my finger, I see I've got 1.2.
Okay.
And if I go up with my finger, I see that I've got 0.08. So that means you have a z-score of 1.28. Make sense?
Okay. Okay. So I'm with you so far.
So far, so good. All right, awesome. So then, once you've got that, you're using the fact that the z-score is always equal to data value minus mean over standard deviation. Does this formula look familiar at all?
Yeah.
Okay, good. So we're just going to take what we have. We have our z-score. It's 1.28. So I'll put that in there. We don't have this x because that's exactly what we're looking for. We're looking for what is that age that separates the top 10% out. So that's still just going to be x. The mean, or the one I'm using, is this 24. That's the value I'm using for this. So I'll put minus 24. and then standard deviation of 2. So now all you've got to do is just solve this equation right here for x. Because we've got everything we want, we've plugged it all in. So if I solve it for x, I would just multiply both sides by 2. So if I do 2 times this, you can throw that in your calculator, you're going to get 2.56. You follow so far? Uh-oh. Are you still there?
Clear?
Still here? Okay, cool.
Hello?
Hello, I can hear you. Can you hear me?
Yeah, I can hear you.
Okay, good. Are you following so far with everything I'm doing?
Yeah.
Okay. So then just solve for this x value here. I'll just add 24 to both sides. And so we get that age would be 26.56 years old. So that would be the age, like 10% of everyone else is older than that, and 90% of everyone else is younger than that.
Okay.
Does that make sense?
That does.
Okay, cool.
I think the teacher said we could use our calculator though. Do you know can you show me that?
Sure, that's what I was going to do right now. So
Okay.
what I will tell you is that if you have one of the newer calculators, it's actually going to ask for 3 things. So first of all, let me show you how to get to where I am, and then I'll write it up here. So on your calculator, make sure it's on, of course. But then if you hit second and then DISTR, that's where the VARS button is.
Underneath the arrow area.
Underneath the arrow area, yeah.
Okay. Yep.
Bottom
there.
Okay. Click that. And do you see how option 3 says INV norm?
Yeah.
Okay, we're going to go ahead and pick that one. So I'll hit 3.
Okay.
And you should see a screen. It's saying area. It's got mu and then sigma in there.
Okay.
Is that what you're seeing?
Yeah, I'm seeing it, but I have one of the newer calculators.
Yeah, so this is on the newer calculators like I have. So,
okay. Cool.
So the area here we're going to put in is 0.9.
Okay.
Type that in. The mu I'm using is 24, so I'll put that in.
24, okay.
And I'm using a standard deviation of 2.
2.
So I'll put that in.
Okay.
And then it says paste, which sounds kind of strange, but just go down to that and hit enter. And it's pasted it onto the front screen here. And if you hit enter again, it actually spits out that final result. Like it does the whole Z calculation for you. And it gives you this right here that data value is the 26.56.
Okay, that was easy.
Yeah, right? So it almost feels too easy with the new calculator, right? It's like, but yeah, you can just throw in those values and you're good to go. Just as a comment, like maybe if you rent out a calculator from somewhere, on the older calculators, what it does is that you actually just put in your alpha. So you'd call this, but all you would put in here is alpha, and instead of spitting out the final result, it actually would give you the Z-score. So it would spit out the Z of 1.28.
Okay. And then we'd have to solve it all over again, I guess.
And then you would go right back over here by hand and do that, yeah. So just if you ever get a calculator and that's like all it lets you do, then you would just go back to this part. Does that make sense?
Okay, but I think, yeah, but I'm going to try to keep the newer one so it saves time.
Yeah. Okay. So that's for part A. That's getting the age, which cuts off like the top 10%. For part B, it's really the same process. It's just that now, instead of doing the top 10% over here, we're doing the bottom 20. And notice when we did top 10, we had to think like, oh, 10% means that 90% is to the left because everything's got to be left to right, right? But here, we're actually looking for the left to right value, the 20%. So we can use an alpha of 0.2 here. Does that difference make sense?
And then we can, yeah, I was going to say, then we could, I guess, just put it right back in the calculator.
You can put it right back. Yeah, you could do all this by hand, or we can just throw it in the calculator. So I take it you'd prefer to use the calculator, yeah?
Yeah, definitely.
Okay. So let's do it. So I'll do second, DISTR, and then INV stands for invert, so invert norm.
Okay.
And then just everything's going to stay the same, but I'm going to put it in an area of 0.2, right? Because that's my new alpha.
Okay.
Okay, so I just do 0.2.
Enter, 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 enter.
Yep, enters everywhere.
One more.
And what did you?
And I'm getting I got 22.31675, blah, blah, blah.
Blah, blah, blah. That's what I got as well. So I'll just write down 22.32. I'm just rounding it. But yeah,
Okay.
that's exactly it. Now, okay, so we've got, and then let me actually write the data value here as well. The 26.56 belongs right here. So those are actually the ages. So this is the age which cuts off the 10%. We just got the age which cuts off the bottom 20%. Now, for part C, it says we want what separates the, like, how exactly did it say it? If you could read it to me again, I'd appreciate it.
Oh, what age separates the top half from the bottom half?
Okay, so half. So
Okay.
So they use the words half right there, so that's really important. So you agree that this normal distribution, the whole thing would be 100%, right?
Right.
So what would half of that be?
50%.
50%. So there's two ways. I'll do the more complicated way first because that's how everyone with math does things, right? So the first thing is half would be 50%. So if I cut right here, the alpha, which is half of this, would be 0.5.
Right.
And then what could you do if you've got your alpha?
We just plug it right back in.
You'd plug it in again.
Invert norm.
Invert norm. Let's do that. Let's see what happens.
Okay. I put in 0.5, I keep it 24, keep 2, paste, enter, and I get 24. This is a nice clean number.
It is very clean. In fact, does it look familiar?
Yeah, isn't that the one that you picked earlier?
That's the one. That's the mu. That's the mean, right? So actually, if you think about it, we didn't even need to use the calculator to do this because we're talking about what separates the top half from the bottom half, right?
Right.
By definition, the mean is the thing which is exactly in the middle of the data. Does that make sense?
Okay. Yeah, that does make sense. So we didn't even have to do all that. We could have just put 24.
Yeah. Yep. That's the value which is right in the middle, and everyone else goes either above or below that.
Okay.
Sense?
I think I got the hang of this. Do you mind if I just sort of go through it and then you pick up if I made a mistake?
Yeah, let me just sort of give myself some room here, just get rid of this in norm, and I got plenty of room right here, so you can just walk me through it.
Okay. All right, so we have top 10%, which means bottom 90.
Mm-hmm.
Okay, and then so I'm going to do second bars or distribution, invert norm, 0.9. The area. This time our mean is actually supposed to be 24.1 because that's the one I have.
That's what you've got.
Enter. And standard deviation of 1.9. Enter. And then one more enter. And then I pasted it and I put it enter. I'm getting 26.5349, et cetera, et cetera.
Okay. And notice that is different enough. Like it's 0.53 instead of 0.56. That is different enough that one would count for points and one would not on a test, right? So.
Right, of course.
Okay, there you
go. All right, so then we do this again for the bottom 20. So second bars, invert norm, 0.9. No. Now we need to change it to 0.2.
Right.
And then we have the same mu, same standard deviation, paste. And then I hit enter, and I get 22.5 and a couple zeros and some other stuff.
Cool. That one's quite a bit more. It's more different, it seems, than the other one we got. In fact, yeah.
Right. And this last one, actually, it's easy. It's just 24.1, right? Because it's whatever the mean was.
Yeah. And why is it whatever the mean was? Just to make sure.
Top 50% is 0.5, so if I were to plug that in, it would just give me whatever the mean was.
You got it.
Right in the middle.
That's exactly it.
So okay. Well, that was easy enough.
Yeah. Statistics is a lot of that, where it's just like once you know what the definitions are, the actual calculations are pretty straightforward.
Awesome. All right. Well, thank you so much. That took a lot less time than I thought it was. That was very painful.
No problem. I'm glad I could help you out.
All right. Have a good one.
You too.